Find the solution of the given initial value problem. So we got a second order differential equation and two initial conditions. So based on this homogeneous differential equation, so we got characteristic equation here, just r squared minus 2r plus 5 equals 0. Using the quadratic formula, we got the roots, it's a complex conjugates, 1 plus minus 2i. Then the solution for the homogeneous equation is based on this real part, e raised to 1t, et, and from 2i times we get cosine and sine. Now we need to apply two initial conditions. For we have two options. We can simply apply pi over 2, this one directly, or we can multiply this solution by a constant so that when we apply pi over 2 for t, this becomes 0. So let's apply directly. So using y at pi over 2 equals 0, that means y value is 0 when t is pi over 2. So this y is 0 and t is pi over 2. So e raised to pi over 2. Okay, this is a decimal number anyways. Inside c1 times cosine 2 times pi over 2. Okay, 2 times pi over 2 is pi. So we got cosine pi. And cosine pi is -1. Okay, so times -1 plus c2 times sine 2 times pi over 2. That's the sine pi. And sine pi is 0. Okay, so this is 0, and we got -c1 times this one. So 0 equals e pi over 2 times -c1. Okay, equals 0 means this is not 0, so -1 times e to the pi over 2, e raised to pi over 2. If we divide by this number and negative as well, so this means c1 equals 0. Okay, now since c1 is 0, we might want to update solution because our solution is here in equation 1 and we are trying to determine c1 and c2. c1 is 0, that helps us simplify, because to apply the second initial condition we need to find derivative. Okay, so before we find the derivative, let's update the solution. Update equation 1. Okay, so that will be y equals then e to the t outside, c1 is 0, so the first term is gone, so times c2 sine 2t. Okay, let me put this equation 1 again, so update it. To apply second initial condition, because second initial condition is given in terms of y prime, so we need to find its derivative. So let's find its derivative. c2 is constant, et sine 2t, two functions, so we must use the product rule. Okay, y prime t equals c2 is just c2, u times v, so derivative of first factor itself, sine 2t, plus derivative of second factor, derivative of sine 2t is cosine 2t times, from the general, derivative of 2t is 2. Okay, that's the derivative of second times the first, at. Okay, our final answer is given from here as soon as we find the value of c2. Okay, now we apply y prime at pi over 2 equals 2 here. Okay, so using y prime at pi over 2 equals 2, so y prime is 2 when t is pi over 2, so that's c2 e raised to pi over 2, okay, times sine 2 times pi over 2, sine pi, which is 0, plus 2 times cosine pi, that's negative 1 times e raised to pi over 2. Okay, so we are trying to determine C2. So this is 2 equals, so this part is gone. So negative 2 e pi over 2, that's the constant, times 2, C2. So C2 times negative 2 e pi over 2. So let's divide both sides by this number so that we get C2. So 2 over negative 2 times e pi over 2, 2 and 2 cancel. So negative 1 over e pi over 2, which is same as if we move up because exponent minus e and negative pi over 2. Oh, that's C2. Now if we plug this back here, we get our final answer. So thus the solution is y equals C2, let me put this first because that's the constant C2, we found minus e raised to negative pi over 2, okay, et sine 2t final.